All right, in this lesson, we are going to learn about special products of polynomials. Special products. Remember, product is the answer to multiplication problems. So we've been doing a lot of multiplication with the distributive property. And in this case, I'm actually going to show you some patterns later on that when you recognize them, it's just you can skip a lot of the middle work that we usually do when we're doing the distributive property. So what I'd like you to do right now is pause it and read this paragraph in blue right here where it says read this, and come on back and I'm going to talk about it. So pretending you came back, some pairs of binomials have special products. Remember, a pair is one quantity and another quantity of two terms. Those are binomials. And when you learn to recognize such pairs, finding the product, remember that's the answer to a multiplication problem, of two binomials, you can be quicker and easier. It can be quicker and easier for you to figure out, because seeing the pattern, learning to recognize the pattern, allows you to jump almost instantly and just write the answer out. So for instance, let's say you have this you're going to multiply these two binomials right here. Y plus 3 times y minus 3. I can tell you right now, because of special products of binomials, you would get an answer of y squared minus 9. The product of multiplying those together, after I multiplied them, distributive property, and then CLT, combine like terms, and then put it together, I would get y squared minus 9. Why is that? How would I know by looking at that I can instantly just write that and have the answer? Because when we use FOIL, we would get y squared. Remember, FOIL would be the first y times y squared, times the outer, so all the way to the outer, a y times a negative 3 gives you a negative 3y. The inner, a positive 3, positive y, gives you a positive 3y. And then the last terms, multiplying those, is positive times a negative is a negative, and squaring 3 gives you 9. So you would have, if I used FOIL, if I did this the long way, I would have y squared minus 3y plus 3y minus 9, which ends up with y squared minus 9 after I combine like terms, just like my original answer there. You're going to learn by recognizing this pattern right here, y plus 3 times y minus 3, how the y's are the same and the 3's are the same but opposite signs right there, that you're going to recognize that as a special case and be able to just instantly write the answer right here, and it's a lot quicker and easier for you. Okay, why can we do that? Because of this first key concept today, sum or difference pattern. That's what it's called, the sum or difference pattern. In this case, we have, there's a sum and a difference here. But what it says, if a times b, sorry, that's a plus b. If this quantity right here, a plus b, multiplied times an a minus b quantity, then I can just write a squared minus b squared. And that would be the answer, because a squared plus ab minus b squared, these come from working these out. A times a is a squared. A times negative b would be a negative ab right here. A positive b times a, that's positive ab, and then the negative b squared. When I combine like terms, I lose the middle terms. They cancel out. And that leaves me with a squared minus b squared. So if I have a situation that I recognize, I can see it, that I have an a term here, an a term here, a b term here, a b term here, but the only thing is the sign is different, then I know I have a sum or difference pattern, and I can just write my answer, a squared minus b squared, and do the work, and we're done. So what that would look like, for instance, let's say 3x minus 4 times 3x minus 4. Same term for the A's, same term for the B's, and this one just happens to be negative, and this is positive. So I have the sum or difference. Difference or sum. It can be either way. It's all right. And therefore, I know that I could just go ahead and take my a squared minus b squared up here and just apply it here. So a squared, 3x, and 3x, that's a 9x squared. That's part of the answer. And the other part is I can just take, I know it's going to be negative. The answer always comes out negative for this part. And I just square the b terms. 4 times 4 is 16. So I end up getting my a squared minus b squared, my a's squared, and my b's squared, and it works out. This would be the answer right here. If you want to see the math, 9x squared, 3x times 3x is 9x squared, 3x times a positive 4 is a positive 12x, negative 4 times a negative 4 times a 3x, that's a negative 12x, and then negative 4 times positive 4 is negative 16. Those cancel out, and again, you get the same answer. That's the sum or difference pattern. So, an example, find the product 5t minus 2 times 5t plus 2. I look at it, I look and go, oh, the a's are the same, the b's are the same, and they have, it's a sum or difference. It's a difference or sum, either way. So the solution is, well, let's just write the pattern. What's the pattern that we just learned? A minus b times a plus b gives me a squared minus b squared. I can just use that, and then I'm going to apply the pattern. So I took this and I just rewrote it right here, and I'm going to apply the pattern. So what's a squared for 5t? 5t times 5t is 25t squared. 25t squared. 2 times 2, that's 4. So 2 squared is 4. And that's going to be that will be a negative sign when I have a sum or difference pattern, which we do here. So this is the answer. All right, your turn right here. I got 3, 1, 2, 3. And I want you to pause it and do it, and then come on back and see how you did. Okay, here we go. Number one, I'm just going to apply the pattern. So this is a plus b, because a plus right there, and a minus b, which I know is just going to be a squared minus b squared. So I just need to apply that to here. What is the square of a? That's x. X squared. Minus, what's the square of 2? 4. Voila. Presto. All done. That's going to be the answer. Number 2, I'm going to skip writing the pattern out this time. I'm just going to do the work. So it's just going to be p squared minus 8 squared. So that's just p squared minus 64. We're done. Last one. Let's see. I didn't use purple yet. Little more information in there. Little 2x and a 5. Same thing though. What is 2x squared minus 5 squared? Well, that's just 4x squared, and 5 times 5 is 25. All right, that's the sum or difference pattern. The second key concept in this lesson is called square of a binomial pattern. Square of a binomial. That means we're going to take a binomial, remember, 2 terms. So that's a binomial, and we are going to square it. So if I have a situation like this, and I said, look, I want you to square a plus b as a as a binomial, which means I'm going to go a plus b times a plus b. Squaring something is multiplying it by itself exactly. So if I have a plus b squared. Then what's going to happen is I'm going to square the a's, and I'm going to add the number 2 multiplied by a and multiplied by b. So there's really there's kind of 2 steps right there. And then I'm going to have I'm going to square b. So I get that. Notice that if it's a plus right here, then I'll be able to use this pattern using the addition sign in between both those terms right there. Why does that work? Well, because a plus b quantity times a plus b quantity again would give me a squared plus ab plus this multiplied together gives me another ab plus a b times a b is a positive b squared. I would combine like terms right there, and I would get a squared plus 2ab plus b squared. That's going to happen all the time. So I can just instantly use this pattern right here, this is square of a binomial pattern, and apply it to something like this. X plus 5 squared. If I just said, hey, if all I have to do is this, then I'm going to get this. So what I would do is a squared. So the a is x. The square of x, just, x times x, x squared. This middle term right here, 2 times ab. So it's going to be 2 times x is 2x times 5, and that's where the 10x comes from. So it's like 2 times x times 5 gave me the 10x. And then, of course, I just square the 5 right there, and that's 25. This is my answer right here. This is what you would see if I had the actual, if I just used the algebra behind it, the a's and b's, this is how it actually plays out for when I apply it to an actual binomial there. That's when it's a sum. That's when it's plus right here. What happens when I have a negative? A little bit different, but almost it's pretty identical except for the signs. So what happens is if I have a minus b squared, then it's going to look like this instead. It'll be a squared minus 2ab plus b squared. So the only change is when you see a negative here, make sure you put a negative here, as opposed to, up here it was plus for both of them. So the only difference is that that is going to be a negative on this case. So let's say we apply it with 2x minus 3 squared. Well, let's take the a's. First thing we're going to do is square the a's. 2 times 2 is 4. X times x, x squared. And I'm just going to go ahead and bring that negative right there. The next thing I'm going to do is 2 times a times b. So it's going to be 2 times 2, which is 4. And the x goes with it. So 4x, I have 4x times b, which is 3, gives me 12. So 4x times 3 is 12x. So the negative can just put right there, and you just multiply 2 times 2x and times a 3, so we get 12x. And then a positive will go here, and this will be taking the 3 right there and squaring that. 3 times 3 is 9. And this is what the pattern would look like. So a squared for that one minus 2ab, that negative 12x is what that worked out to when I applied it, and then the positive b squared. That's the square of binomial pattern. One will be with a plus, one will be with a minus. And these are the patterns that you're going to use to just, really, you're just going to rewrite that. But that's the answer. Okay, really quick lesson. This is the last step. I want you to apply, I want you to try it out on what you did here, and then I'm going to go ahead and work it out. So pause, and I'll see you in a couple seconds. Okay. On the first one right here, I'm gonna apply the pattern. Does anybody remember? I mean, if you remember what the pattern was, that's a positive right there. So the pattern was, I need to make it look like a squared plus 2ab plus b squared. That's the pattern. So I'm going to take the a, which is 3n, and square it. I know that's 9n squared. The plus comes down here. Now I'm going to do 2 times 3n, 6n, 6n times b, which is 4. That is a 24n. And bring the addition sign down, b squared. So I look at the 4, and that's going to be 16. And that is it right there. Wow. We're very, very fast. Number 5 over here, I think I'll do it in purple. A little bit different. I have another variable in there, but no problem. I'm going to write it. This is negative, so if you remember, this is actually going to be a squared minus 2ab this time, plus the b squared on the end. Okay. Take a and square it. 4x squared. Take the 2. 2 times 2 is 4, and then we're gonna have to go ahead and multiply it with the 7 over there. So really, right now, I'm gonna show you what we're doing. We're gonna take the 2, and we're gonna have to multiply it times a, and we're also gonna multiply it times b, which is 7y. All of that inside. And then I'm going to come back, I'm just going to go ahead and knock this out over here. This is going to be 49y squared. So I gotta work out that middle part right there. All right, nothing happens here. 4x squared minus, so I'm just going to work this out. 2 times 2x is 4x, and I still got to multiply it times the 7y. 4 times 7 is 28. And the x and the y, they just stay together like that. So this ends up being 4x squared minus 28xy, and then we can bring down the 49 right there. 49y squared. Okay, so a little bit more tricky if we have 2 variables in there. But this might be a great way for you to do yours. Put it, there's the 2, here's the a, here's the b, and just get used to it. You're going to multiply them all together. 2 times 2x is 4x, and 2 times 2 is 4x. So then I'm going to do 4x times 7y. These are going to be multiplied together next. And 4 times 7 is 28, and x times y is the same as xy. So 4x squared minus 28xy plus 49y squared would be the correct answer for this one. And that is it for the two key concepts of square of a binomial pattern and then the sum or difference. So these are special products, stuff that if you can see ahead of time what you're looking at, it's going to make it a little easier for you, and you can just write the answer out. See you in class.